Computational Methodologies is focused on experimental validation of gas-cooled reactor simulations. High-quality data is needed for the validation of system and computational fluid dynamics models of high-temperature gas-cooled reactor phenomena. Phenomena of interest have been identified as those relevant to core safety and performance, but the data is insufficient to allow validation of models and codes. Specifically, the phenomena of interest include air and water ingress, core heat transfer, plenum-to-plenum heat transfer by natural circulation, heated two-component stratified flow in the outlet plenum, bypass flow between fuel or reflector blocks, dust and fission product transport in the reactor coolant system, and the performance of reactor cavity cooling systems in cooling the reactor pressure vessel. Validation of computer codes that capture phenomena relevant to core safety and performance requires the coordinated completion of a number of fundamental separate effects and mixed effects tests, such as combined mass flow and heat transfer and integral tests. These tests must be properly scaled to reproduce the thermal fluid conditions bounding a gas-cooled reactor under normal and accident scenarios. Because integral testing facilities are generally large, long-term investments, they are beyond the scope of any UP awards. However, several facilities have been built using other sources of funding. Examples of these facilities include the High Temperature Test Facility at Oregon State University, the Natural Circulation Shutdown Test Facility at Argonne National Laboratory, and the Mixed Index of Refraction Facility at the Idaho National Laboratory. These facilities are available for integral tests and can complement the smaller and generally less expensive experiments that can be effectively conducted at a university. Proposals are sought that will fill the gaps in the data needed for high-temperature reactor code validation with appropriately scaled experiments, especially experiments that complement those that have been or can be conducted at the facilities that I just mentioned. And additionally, you may propose the use of other suitable integral facilities not identified here. Investigators who wish to propose new experiments using one or more of these facilities are strongly urged to coordinate with the principal investigators at these facilities before submitting the final proposal to obtain guidance on cost, schedule, and quality assurance. If you do submit a full proposal, I assure you that I do look at your cost estimates to ensure that you have planned to coordinate your efforts. Experimental investigations must be conducted in conjunction with pre-test and post-test simulations using system, computational fluid dynamics, or other suitable codes. Emphasis of this work scope is on the generation of high-quality experimental data that can be used for the validation of different analysis codes rather than the development of these codes. Please note that all data and simulation results are to be uploaded, preferably in real time, and archived on the NGNP Data Management and Analysis System hosted at the Idaho National Laboratory. Investigators are strongly urged to coordinate with the INL personnel to link to the INL Data Management System. Contact information for INL and integral facility personnel can be obtained from the points of contact listed in the work scope. In summary, a range of supporting, scaled, fundamental, separate, and mixed effects experiments are needed. The experiments must be scaled to reproduce anticipated conditions in the system referenced in the work scope and could complement past or current experiments at existing facilities. Your work must be accompanied by pre- and post-test analysis. New measurement techniques are encouraged, and all validation and verification work must be performed using NQA-1 2008 with the 2009 NRC accepted paragraphs on quality assurance practices. Thank you very much.